We have talked in previous videos about alchemy, where you're trying to add or subtract a proton. You can't do that. If you remove a proton, it turns it into another element. We don't do that. We have also talked about isotopes, where you add or subtract a neutron. So remembering, because protons plus neutrons is the total mass of the atom mostly, and therefore if you change the number of neutrons an element has, then you have changed the mass of that element. But today's lecture, we're going to focus in on ions. Ions are going to focus on the subatomic particle of the electron. And so what's going to happen as you add or subtract an electron, then you're either adding negative charge or taking away negative charge, depending on if you're adding electrons or taking them away. If an ion has lost an electron, it has become more positive, and that's going to be called a cation. If an ion has gained an electron, then it's going to be gaining a negative particle, so therefore it's becoming negative, and that is going to be called an anion. You'll want to be very familiar with those two words, cation and anion, as I will use them regularly. I like this little comic. It helps me remember which one's which. The cations, they're positive. I love Chemistry Cat. He's cute. I also remember it this way. Cation has a T in it, and I think the T looks like a plus sign. So cations are positive. Also, anions have two N's, and so they're negative. So those are other little clues to kind of help you remember. But cations are positive and anions are negative. All right, so how do we know if a molecule, a neutral molecule, is going to become a more positive or a more negative substance? Because your ion charge is going to be your protons minus your electrons. So if you have more electrons, it's going to be negative, and if you have more positive protons, then your ion charge is going to be positive. So if you have a hydrogen ion, which is shown here below, how many protons does it have? Hopefully you realize that the hydrogen ion has an atomic number of 1, and you're not changing the protons by changing its charge. It has 1 proton. But how many electrons do you think it has? In order for it to be a plus 1 charge, and it has 1 proton, it must have 0 electrons, because 1 minus 0 is going to be 1. And that's why you see that little plus next to it. And you only see 1 plus. It's an understood one. So it's plus 1 charge. So it's got 1 proton and absolutely no electrons. A concept that's important to consider is total electrons versus valence electrons. Pretty much up until this point, we've been discussing total electrons. Valence electrons, though, are what are going to be the most active electrons in the atom, and those are going to be the ones that are going to be most involved in bonding. And so in understanding electron charge and in understanding bonding, we need to separate valence versus total. Valence just means those electrons that are in the outer ring or outer orbitals of an atom. The total electrons is going to depend on the charge. And so these two are going to be related very intrinsically as we move forward. Pull out your periodic table, because I think that's the best way to figure out valence electrons. So when you're looking at your periodic table, notice all of these numbers that are circled. Now we're not going to worry about the transition metals or the lanthanides or the actinides. That's for another course, not for this one. For our course, when we're talking about valence electrons, we're just going to be looking at these alkali metals, alkaline earth metals, and then all of those on the right, groups 3 through 8. These are the ones we care about. So if I were to ask you how many valence electrons are in group 1, and the answer is 1. How many valence electrons are in group 3? The answer is 3. And we'll figure out why in more detail as this class progresses. But for right now, circle those numbers on your periodic table and be ready to answer. So if I say, how many valence electrons does phosphorus have? You would go over and look at element number 15, the P for phosphorus, and you would say, oh, it is in group 5A, therefore it has 5 valence electrons in its outer shell. And that's very important. And that leads us to figuring out how many, what charge it's going to have or what type of ion it's going to be. Now there is an exception. Look up here at helium. Helium only has 2 electrons, but you'll see it sometimes in some periodic table charts above the group 2A and sometimes over here with the noble gases. It is a noble gas, and it's just very stable, and so that's why it's over there. So just remember, helium has 2 electrons, not 8. Okay, and if you remember that, that's the one exception. All right, so now what charges do we have? Well, what we're looking at here in this chart is the most common charges that these elements are going to form. So like lithium, sodium, all of those are in group 1A, so they're going to form a +1 charge. And the reason for that is in that outer shell, all of these elements want to become what's called stable. They want to be very stable. And so if you have one valence electron all by itself in the outer shell, it wants to get rid of that one so that way its outer shell is now full and happier. And so lithium wants to form a +1. Beryllium wants to form a +2. So all group 2A ones will form a 2+. And then 3A is going to be, aluminum, gallium, indium. All of those are going to form a 3+ charge. So just write these on your periodic table. Even on your test, the very first thing I would suggest doing is just pulling it out and writing these numbers on your periodic table, and then you can use it through the whole exam. So they always form those charges. And then group 6 and 7 will form your negative anions. And then 8 is stable, so it actually doesn't need any. It doesn't really form ions. So, and the reason for that is because you want your outer shell to either contain 2 for your hydrogen or your helium, or every element wants to attain 8 electrons in its outer shell. So when we look at lithium, it only has 1 in its outer shell. So how can it become stable? It's a lot easier to just lose 1 electron. Whereas fluorine, it has 7 electrons in its outer shell. So to get to 8, it's a lot easier just to gain an electron. And when you gain an electron, you're gaining a negative particle, so it makes it be -1 charge. Look at calcium. Calcium has 2 electrons in its outer shell. So if it loses those 2, it's a lot easier to lose 2 and get to 0 than it is to gain 6 and get to 8. So really you're asking the question, is the valence electrons closer to 0 or is it closer to 8? And if it's closer to 0, it's going to form a positive charge. If it's closer to 8, it's going to form a negative charge. Now you might ask the question, what about group 4 and group 5? Well, they're kind of in the middle. So those group 5As, they could form 3+ charges, and they do regularly. Or 3 negative charges, excuse me. They do form 3 negative charges. But they could also be neutral, and they could do what's called covalent bonding, which we'll get into later. But for right now, just note that your 5As, those are going to mainly be -3. But your group 4As, those are right in the middle, and so they don't typically form a lot of ions. That's your carbon. They don't form a lot of ions just because 4 is right in the middle of 0 and 8, so it's like it can't make up its mind, so it just doesn't. It doesn't form those ions. And so whenever we're looking at this chart, just pull it out anytime we talk about ions, anytime I ask you to identify subatomic particles in an ion, and this will help you figure out what charge it forms. Because on a regular basis, I'm just going to name an element and say, hey, aluminum, what ion does aluminum form? And you'll be able to look at your periodic table and say, oh, it's in group 3A, so it forms a 3+ charge, a cation.